Welcome to part test 8 chemistry paper discussion. So in this first question, it is given A giving rise to B and the rate constant K is given as 1.2 into 10 to the power minus 2 molarity per second. So from the units we can understand that it is a zero order reaction. For zero order reaction, so the initial concentration, final concentration, they are related as A is equal to A naught minus KT. So in this question they are asking final concentration when the initial concentration is 10 molar and K value is also given, temperature time is also mentioned. So here A is equal to 10 minus K is equal to 1.2 into 10 to the power minus 2 into time is 10 minutes, that means 600 seconds. So here, so this 2 get cancelled, so it will be 10 minus 1.2 into 6, that is 10 minus 7.2. so the final answer will be 2.8 molar, that is the final solution concentration. In this question, H2 plus CO2 giving rise to H2 plus H2O and CO. Okay, and here the number of moles, these are all gases. So the number of moles of the products is equal to number of moles of the gaseous reactants. So therefore delta N is equal to 0. When delta N is 0, Kp will be equal to Kc. Okay, so here the Kp is given 0.16. So we are taking this Kp value also as 0.2. So the Kc value will also be 0.16. Okay, so again the question is if 0.25 moles is taken. So if H2 plus CO2, again I am writing this as H2O plus CO. So if 0.25 moles is taken, H2 and CO2, then what will be the mole percentage of CO? So this is the question. So we don't know that what will be the degree of dissociation. So out of 0.25, if X is the amount dissociating, that is the amount reacted. Similarly here also it is 0.25 minus X. So this is the remaining concentration. And definitely if X is reacting, X amount of H2O will be formed and X amount of CO will be formed. Now Kc, that is 0.16 is equal to concentration of the products, that is X into X divided by concentration of the reactants, that is 0.25 minus X into 0.25 minus X. So this can be simplified to 0.4 is equal to X by 0.25 minus X. Now this X will be equal to 0.4 into 0.25 minus X, which is equal to 0.1 minus 0.4x. Now 1.4x will be equal to 0.1 and x will be equal to 0.1 by 1.4, which is again 1 by 14. Now we know that, now we got that this x is 1 by 14 moles. Now you have to find out the percentage of CO by mole percentage. That means percentage of CO is equal to number of moles of CO divided by N total. That is 1 by 14 divided by total moles, that is 0.25 minus X plus 0.25 minus X. So these are the moles of the H2, these are the moles of the CO2 remaining, plus X plus X. So these things get cancelled. So the total moles is also 0.5. So percentage is equal to 1 by 14 into 0.5 into 100, because they are asking percentage. So this will be 200. So this is 200 divided by 14 and 100 by 7, and this is nearly 14. Answer will be option B. Decomposition of ozone follows given mechanism. See, ozone is decomposing in two steps. In one step it is forming O2 plus O. In the second step, this oxygen is combining with O3 to form 2O2. So here this is the fast step and this is the slow step. And the rate of it is a complex reaction. So rate of a reaction depends upon the slowest step. Therefore rate we can write it as K into concentration of O and concentration of O3. But this O is a intermediate and we should express concentration only in terms of reactants. So for this we take the help of this equilibrium step. So if we assume that Kf is the rate constant for forward reaction, Kb is the rate constant for backward reaction. Now Kf by Kb will be equal to O2 concentration, O concentration. These are the products divided by concentration of O3. Now the concentration of O3 can be obtained as O can be obtained as Kf by Kb into O3 concentration divided by O2 concentration. Now we can substitute this concentration of O, this one here. Okay, so now rate will be equal to K into Kf divided by Kb into concentration of O3 divided by concentration of O2, and this O3 is already there, so this is concentration of O3. Okay, so finally this will be rate will be equal to K effective into concentration of O3 power 2 and concentration of O2 power 1. Now if you look at each statement, now you can understand that first statement is overall rate will be dependent on rate of second step. Yes, it is correct, because rate depends upon the slower step. And again order of the reaction is equal to 2. So this is the thing. Here overall order is equal to 2 minus 1, that is 1, but it is mentioned it is 2. So this is a wrong statement. Molecularity of step 2 will be 2. It is also correct. For an elementary reaction, molecularity will be the number of moles of the reactants involved, and it is also correct. Rate of formation of ozone will decrease with increase in concentration of the oxygen gas. Yes, from this rate law you can understand that rate is inversely related to O2 concentration. So this is also correct. So the wrong statement is B. This is the correct answer. When half-life period of zero order reaction is plotted. Okay, so for zero order reaction, half-life and concentration, these are related as T off is equal to A0 by 2K. So half-life is directly proportional to initial concentration. So you get a straight line with a positive slope. The rate constant for the first order reaction is 30 per second. Okay, so it is a first order reaction, and the K value is given as 30 per second. How much time it will take to reduce the concentration to 1 by 8th? Okay, so if it is K is given, so T can be obtained as through the formula 2.3 divided by K log base 10 concentration of the initial concentration divided by final concentration. So here K value is given as 2.3 divided by 30 into log base 10. Initial concentration, if it is 1, the final concentration it is 1 by 8th. Okay, so this will be 2.3 divided by 30 log base 10 8. Okay, now this can be further simplified to 2.3 divided by 30 log base 10 2 to the power 3. So this is again 2.3 divided by 30 into 3 into 0.3. So this is 2.3 divided by 30 into 0.9. Now this I can write this as 2.3 into 9 or 90 into 10 to the power minus 2 divided by 30. So this is 6.9 into 10 to the power minus 2. So answer will be option A. Identify the incorrect statement. So first statement is Ag plus is a stronger Lewis acid than Na plus. This is correct because Ag plus is a D block element, and for D block elements the core electrons will be present in F and D subshells. So because they are poor in shielding, because of their poor shielding effect, so the effective nuclear charge will be very large and they act as strong Lewis acids. So first statement is correct. Second statement, pH of pure water remains same at different temperatures. So pH of water at 25 degrees is 7 because at 25 degrees hydrogen ion concentration is 10 to the power minus 7. But if we increase temperature, if temperature is increased, hydrogen ion concentration will increase. Therefore pH will decrease, pH will become less than 7. So here the statement pH of pure water remains same at different temperatures, this is wrong. pH changes, but overall water will be neutral because the H plus ion concentration and OH minus concentration will be equal. Okay, so here option B is incorrect, that will be the answer. And let's see option C and D also. AgCl is more soluble in water than in AgCl is more soluble in water than in aqueous NaCl. Yes, if you take pure water and if you take an aqueous solution of NaCl, so AgCl will be more soluble in water because of the common ion effect. Here there is a Cl minus ion in the solution. So AgCl in water will be more soluble. CH3COO minus is a weaker base than OH minus. It is also correct because CH3COO minus due to resonance it is stabilized, so it is less basic. So the correct option is B. In a first order reaction, concentration of the reactant decreases from 800 to 50. The rate constant will be, so here they are asking again K value. So again this K value will be equal to 2.3 divided by T log base 10 initial concentration divided by final concentration. So here 2.3 and T is mentioned as 2 into 10 to the power 2, that is 200, and log base 10 initial concentration is 800 and final concentration is 50, so this is 16. So it is 2.3 divided by 200 and log base 10, 16 is 2 to the power 4, so this will be 2.3 into 2.3 divided by 200 log into 4 into 0.3. So now we can further simplify this. 2.3 divided by 200 into 1.2. So this will be 0.6, 100, and this will be 1.38 divided by 100 will be equal to 1.38 into 10 to the power minus 2. Option C will be the answer. pH of 0.01 molar solution of weak monobasic acid is, see, a weak acid is there, Ha, and it will dissociate into H plus and A minus. Its concentration is given as 0.01 molar. But weak acid does not dissociate completely, so the concentration of H plus will be lesser than 0.01 molar. So for this, if we assume that alpha is a degree of dissociation, So it is 0. Alpha will be equal to K by C root over for a weak acid. So here alpha will be equal to K is given as 6.6 into 10 to the power minus 4 divided by C is given as 10 to the power minus 2 root over. Okay, if you solve this further, so this will be 10 to the power minus 2. So this is 6.6 into 10 to the power minus 2 root over. Okay, if you follow this further, you will get 0.217 as the answer. Now this is alpha value. Now what is C alpha? So this C alpha will be hydrogen ion concentration. This is equal to 10 to the power minus 2 into 0.217. So we can so this we can get as 2.17 into 10 to the power minus 3. Okay, so this is 2.5 you will get. So this is 2.5 into 10 to the power minus 3. So hydrogen ion concentration will be equal to minus log 2.5 into 10 to the power minus 3. So this will be 3 minus log 2.5, that is 3 minus log, if you take 10 by 4, so log base 10 is equal to 1, and this will be 0.6. 3 minus 0.4, it will be 2.6. Answer will be C. It is an SN1 reaction. See, remember, for an SN1 reaction, rate of the reaction depends on stability of the carbocation. Stability of carbocation intermediate. So in the first question, in the first structure, the resulting carbocation will be secondary carbocation. For the second structure, the resulting carbocation will be primary, and third structure will give rise to benzyl carbocation. So we know that benzyl carbocations are stable because of resonance, and among secondary and primary, secondary is more stable than primary carbocation. So order of reactivity will be 3 greater than 1 greater than 2. So answer will be option B. So it is a precipitation reaction. So here all these compounds are consisting of halogen. So here there are 2 halogens. When these compounds are treated with AgNO3, see, Ag plus has very good affinity for halogens. They combine with halogen to form salts. Okay, so here you should remember that this Ag plus can only abstract the halogen which is attached to sp3 carbon. So here in all these 1, 2, 3, the halogen is attached to directly to benzene ring. So here only option 4 will form AgI. So only iodine from only fourth compound is abstracted. So option will be 4. 4 will be this one, B. So here you have a carbonyl compound. This is CH3, and it is treated with NaOH. So NaOH will abstract alpha proton, and it will give rise to RC double bond OCH2 minus carbanion. It is nucleophile. It will further react with CH3 CH2 Br methyl bromide. So this is nucleophile and this is electrophile. Again nucleophilic attack. So finally you will get RC double bond O CH2 CH2 CH3. So the answer will be C. The pair from the following which has both non-zero dipole moment. See, in option C, trans-2-butene has non-zero dipole moment. In option B, 1,4-dichlorobenzene has zero dipole moment, and from option D, benzene has zero dipole moment. So in only option A, both the compounds like CH2 Cl2, so the dipole moment is non-zero, and CHCl3, here also the dipole moment is non-zero. Okay, so option A will be correct. 25 ml of silver nitrate solution is added dropwise to potassium iodide. See, AgNO3 is added to potassium iodide, and it is mentioned 25 ml 1 molar, and it is also 25 ml 1.05 molar, and they react to produce AgI plus KNO3. See, remember, in this the AgI is insoluble in water and it is precipitated. So this we have seen earlier also, in earlier question also. So since they are asking the ion present in very small quantity in the solution is, since it is precipitated, both Ag plus and I minus are present in least quantity, that is option B. So in this question, a secondary alcohol is given. It is treated with sodium iodide H3PO4. So when NaIH3PO4 are combined, it will produce a HI. So this HI will react with alcohol to produce alkyl iodide. This alkyl iodide, when treated with magnesium, a Grignard reagent is produced. Okay, and when it is treated with deuterium D2O, so here the negatively charged carbon attacks deuterium atom, and finally you get a deuterated compound as the final product. So it is option D. Aqueous solution of ammonium carbonate is basic. So ammonium carbonate NH4 twice CO3, it is basic. Yes, it is correct. And statement 2, acidic basic nature of salt solution of a weak acid weak base depends on Ka Kb values. It is also correct. Here this salt is made up of two bases, NH4OH, weak base NH4OH and H2CO3, which is weak acid. So if you compare the Ka and Kb values, Kb and Ka values, the Kb value for NH4OH is larger than the Ka value of H2CO3. So that is why this salt is basic. So both the statements are correct. Activation energy for any chemical reaction can be calculated if we know. According to Arrhenius equation, you can obtain activation energy through this equation. Log K2 by K1 is equal to EA, that is activation energy, divided by 2.3 into R 1 by T1 minus 1 by T2. So here K2 and K1 are the rate constants at temperature T2 and T1. At temperature T2 and T1. So if you know rate constants K2, K1 at T and different temperatures, you can find the activation energy. So the correct answer is rate constant at two different temperatures must be known. Option D. A buffer solution is a mixture of salt and an acid or a base mixture. See, a buffer solution is a mixture of weak acid or it's a salt with strong base, or a weak base and it's salt with strong acid. So option first statement is incorrect. Blood is naturally occurring buffer solution whose pH is maintained by H2CO3, HCO3 concentrations. This is correct statement. So statement 1 is wrong, statement 2 is correct. So for this answer will be option D. The ratio of solubility of AgCl in 0.1 molar KgCl. So AgCl dissociate as Ag plus and Cl minus. So if S is the molarity of AgCl, it will produce equal amounts of Ag plus and Cl minus. So it will be S molarity of Ag plus and molarity of Cl minus is also S. Now Ksp will be equal to concentration of Ag plus, that is S into concentration of Cl minus, it is S square. Now the Ksp value is given as 10 to the power minus 10. So from this S can be obtained as S is equal to Ksp root over, that is 10 to the power minus 10 root over, that is 10 to the power minus 5. So this is in pure water. This is in pure H2O. So in the second case, AgCl when dissolved in water, AgCl when dissolved in a solution having 0.1 molar KCl. So there is already Cl minus ions here. So what is its concentration? 0.1 molar. Now due to common ion effect, the dissociation of AgCl decreases. So the Ag plus concentration will be decreased. Okay, now the Ksp value will be same, that is 10 to the power minus 10. It is equal to concentration of Ag plus, it is X, and concentration of Cl minus, this is 0.1. Now X will be 10 to the power minus 9. Now they are asking what is the ratio of solubility in 0.1 molar KCl. So solubility in 0.1 molar KCl is 10 to the power minus 9. In pure water it is 10 to the power minus 5. So the ratio is 10 to the power minus 4 divided by 1. So answer will be A. A buffer solution is prepared by mixing 0.01 molar HCN and KCl. Yes, so this is a buffer solution, and here HCN is 0.01 molar and NaCN is 0.02 molar. Okay, so they are asking what will be the hydrogen ion concentration. Okay, so you can clearly understand that here hydrogen ion concentration is only due to HCN. So now HCN, when it dissociates as H plus and Cn minus ions, and the Ka value for this it is given as 6.6 into 10 to the power minus 10. Now for a weak acid, the Ka value, Ka is equal to concentration of H plus and concentration of Cn minus divided by HCN concentration. So now here there is also NaCN in the reaction mixture. So this Cn minus is due to NaCN. So this concentration will be 0.02 molar. And HCN, because it is a weak acid, it does not dissociate completely. So its concentration will be almost equal to 0.01 molar. So now if you substitute this value, 6.6 into 10 to the power minus 10 is equal to concentration of H plus into 2 into 10 to the power minus 2 divided by 10 to the power minus 2. So these two get cancelled. Now H plus concentration will be equal to 6.6 into 10 to the power minus 10 divided by 2. So that is 3.3 into 10 to the power minus 10 molar. Answer will be option B. So here a rock initially it is consisting of strontium to barium in the ratio 3:1. Okay, so here we should assume that again the reaction is mentioned, it is rubidium. So initially rubidium will disintegrate into strontium through a radioactive decay. So we should assume here that the initially rock will have rubidium, through time it is disintegrating into strontium. So the final concentrations are here, it is strontium 3 parts and rubidium 1 part. Okay, so in percentage wise it is 75% and rubidium is 25%. So rubidium is disintegrating here. So if it is for 50% conversion, so the T of for 50% conversion, it is given that 5 into 10 to the power 10 years will take. For converting from 100 to 25%, what will be the time? So 100 to 50, it is 1 T off, and 50 to 25, this is another T off. So this is 5 into 10 to the power 10 plus 5 into 10 to the power 10. So this is 10 into 10 to the power 10. So this is 10 to the power 11 years it will take for rubidium to disintegrate to 25% final concentration. So answer will be 10 to the power 11 years. So Y will be 11. At 27 degrees, N2O4 dissociate into 2NO2. Okay. So at equilibrium, the pressure is mentioned as 1 atmosphere. Okay. And the degree of dissociation, alpha is 0.2 or 20%. Okay. The question is, what is the degree of dissociation at equilibrium pressure of 0.1 atmosphere? So here we don't know the number of moles of N2O4. So we assume that initially it is 1 mole and it is 0. And 1, if X is the, yes, here it is degree of dissociation is given 0.2. So out of 1, 0.2 is reacting. So it will produce 0.4 moles of NO2. Okay. So the total number of moles will be, N total will be 1 minus 0.2 plus 0.4, this is 1.2. So now we can get Kp value for this. Kp will be equal to partial pressure of NO2 power 2 divided by partial pressure of N2O4. Okay. So here partial pressure can be obtained as partial pressure of NO2, it is equal to 0.4 divided by 1.2 into total pressure. So this is mole fraction and this is total pressure. Okay. So this is 1 by 3, and similarly partial pressure of N2O4 will be equal to, see, out of 1, if 0.2 is reacting, remaining is 0.8, and again total is 1.2 and total pressure is 1. So this is 2 by 3. Okay. So now we can get Kp value for this. Kp is equal to partial pressure of NO2, that is 1 by 3 power 2, that means 1 by 3 into 1 by 3 divided by partial pressure of N2O4 is 2 by 3. So this is 1 by 9 into 3 by 2. So this is 1 by 6. So this is 0.17, which is Kp value. Now they are asking what is the partial pressure, what will be the degree of dissociation at 0.1 atmosphere. Again, at equilibrium, if 0.1 atmosphere is the pressure, then what is the degree of dissociation? Okay. Again, we assume that 1 mole is dissociating. Okay. If 1 mole is dissociating, we don't know the degree of dissociation now. So we assume it is 1 minus x and this is 2x. Now this is number of moles of NO2 and this is the number of moles of N2O4 remaining. Okay. Now partial pressure of N2O4 will be equal to the total pressure 1 minus x divided by 1 plus x into 0.1, and the partial pressure of NO2 will be equal to 2x divided by 1 plus x 0.1. Now we know that Kp value is 0.17. So we should get 0.17 is equal to partial pressure of NO2, partial pressure of N2O4 ratio we should take. So what is NO2? 2x divided by 1 plus x into 0.1 power 2 divided by 1 minus x by 1 plus x into 0.1. So if you solve this for x, you will get 0.55 answer, and percentage will be 55%. So answer will be 55%. The solubility product of AB2 is, see here, AB2 is dissociating as A plus 2 and 2B minus. Okay, if it is S, it will be also S, and this will be 2S. Okay, now KSP will be equal to 3S cube. Now KSP is given as 3.2 into 10 to the power minus 11 is equal to 3S cube. They are asking what will be the S value. So this will be 4S cube. So 4S cube is equal to 3.2 into 10 to the power minus 11, and S cube will be equal to 0.8 into 10 to the power minus 11. Now S cube can be obtained as, so S cube will be equal to, I will write it as 8 into 10 to the power minus 12, and S will be equal to 2 into 10 to the power minus 4. So here the answer will be 2. If T50 is the time required for 50% completion, and T87.5 is the time required for 87.5% completion, they are asking what is the relation between T87.5 and T50. See, the question is T87.5 is equal to how many times T50. See here, if the completion is 87.5, what will be remaining? 100 minus 87.5, that is 12.5. Suppose we started the reaction with 100. In the first T off, it will convert into 50%. In the second T off, it will convert into 25%. In the third T off, it will be converting into half of that is 12.5%. So for 100 to 12.5% conversion, there will be 3 T off involved. Okay, so the question is here, the answer is T87.5 is equal to 3 into T50. So answer will be 3. In this equation, N2 plus 3H2 giving rise to 2NH3, the concentrations of N2, H2 and NH3 at equilibrium are given. N2 concentration is 2 into 10 to the power minus 2, and it is H2 is 3 into 10 to the power minus 2, and ammonia is 1.5 into 10 to the power minus 2. They are asking what is equilibrium constant value. So for this reaction, K will be equal to NH3 concentration power 2 and concentration of N2 into concentration of H2 power 3. Okay, just substituting these values, NH3 will be, concentration will be 1.5 into 10 to the power minus 2 into 1.5 into 10 to the power minus 2 divided by concentration of N2 is 2 into 10 to the power minus 2 into concentration of H2 will be 3 into 10 to the power minus 2. This is 3 times. 3 into 10 to the power minus 2, 3 into 10 to the power minus 2. Now these things get cancelled. 1.5, this will cancel for 2, and this is also cancelled for 2. So now I have 1 by 2 into 3 into 3 into 3 into 3 into 2 into 3 into 2 into 2. So these are 2. Okay, into 10 to the power minus 4. So this is 6, 12, 1 by 24 into 10 to the power minus 4. So this is 10,000 divided by 24. So 24 4 is 96. So the answer will be nearly 416 answer. Okay, thank you.